Ram Run. It's a fun name. You and the historians are looking a lot more pixelated than you remember. You're inside a computer at the North Pole. Oh boy. Just as you're about to check your surroundings, just as you're about to check out your surroundings, a program runs up to you. Quote, this region of memory isn't safe. The user misunderstood what a push-down automation is, and their algorithm is pushing whole bytes down on top of us. Run. Okay? The algorithm is fast. It's going to cause a byte to fall into your memory space once every nanosecond. Oh boy. Fortunately, you're faster, and by quickly scanning the algorithm, you create a list of which bytes will fall, your puzzle input, in the order they'll land in your memory space. Okay. I'm picturing like Tetris, but we'll see. Your memory space is a two-dimensional grid with coordinates that range from 0 to 70, both horizontally and vertically. Okay, cool, so they just give us the bounds here. However, for the sake of the example, suppose you're on a smaller grid, okay, with coordinates that range from 0 to 6. Got it. And the following list of incoming bytes. Oh, cool, so just x comma y, I'm guessing. Each byte position is given as x comma y coordinates, nice, where x is the distance from the left edge and y is the distance from the top. Okay, so exactly how we've been doing it up until now. You and the historians are currently in the top left corner of the memory. Okay, so we're at 0, 0, and we have to reach the bottom right corner at 70, 70. 70, 70. Wouldn't it be 69, 69? Oh, they range from 0 to 70. Okay, so the width and height would actually be 71. Okay, okay. These are worded really well, which is nice. So 6, 6 in the example, they have width of 7 because they run from 0 to 6. Okay, we're good. You'll need to simulate the falling byte to plan out where it will be safe to run. For now, simulate just the first few bytes falling in your memory space. As bytes fall into your memory space, they make the coordinate corrupted. Okay. Corrupted memory cannot be entered by you or the historians, so you'll need to plan your route carefully. Sounds like we're just creating obstacles. Okay. You also cannot leave the boundaries of the memory space. Your only hope is to reach the exit. Okay, I mean, we're maze solving here. Yep. In the above example, if you were to draw the memory space after the first 12 bytes have fallen using period for safe and pound sign for corrupted, it would look like this. Okay, yeah, cool. We've seen this a million times. You can take steps up, down, left, or right. After just 12 bytes have corrupted the locations in your memory space, the shortest path from top left corner to the exit would take 22 steps. Okay, so we're just doing literal shortest path maze solving algorithm. Simulate the first kilobyte, 1024 bytes, falling in your memory space. Afterward, what is the minimum number of steps to reach the exit? Okay, so when I heard down, that memory was falling down, I pictured down as in up in the y coordinate, and I thought these were gonna like fall like Tetris pieces and they were gonna have to like fit into each other, like gravity, but I don't think that's the case. I think this puzzle means we're looking down at a two-dimensional grid, and the down that they're talking about is the z-axis, so like bloop, this coordinate's corrupted, boom, this one's corrupted, boom, this one's corrupted, but from our point of view, it's just a two-dimensional maze. If I'm reading this correctly, this is just create a maze and then solve it as fast as you possibly can. Which, I mean, I've done that logic before, so I'm a little bit worried by how straightforward part 1 is, because that makes me worried about what part 2 is going to look like. But let's go ahead and get started. What's up, Revisualize? How you doing? Let's go over here, make dir day 18, cd into that dir. Let's do the example input.text, and I'll go and grab that from the website, which was just a list of coordinates. And we were only supposed to simulate a certain number of them. Okay. So let's go here. There we go, now we have our example input. Let's grab our real input.text. I will stop screen share for this. Oh my god, that's a lot of input. Okay. Took a while to even paste. Cool. Shares back up. Yo, what's up, tablet Lenovo? How you doing? Solving a maze. And what was the example? The example was range from 0 to 6, so width of 7, height of 7. We need to simulate just the first few bytes. Okay, so 12. 12 bytes is what was simulated in this, and we know that it would take 22 steps with 12 bytes. Okay, so let's go ahead and write code to make that happen. Alright, so we got this. Let's go ahead and work on part 1. What do we need to do? We need to create a grid. So we'll create an associative array called grid. Before we do that, we know the width and we know the height. the width is 7, and the height is 7. This is just for the examples. So then we can just do for y equals 0, y less than height, y plus plus, do. We're going to initialize the grid, and the way we're going to do this is we're going to initialize every single spot in the grid as safe. Grid x comma y equals period. Let's go ahead and grab a print grid, because I know we've written this function 8,000 times. So let's go ahead and grab a print grid function that we can actually use. Actually, you know, might make sense just to reuse it, but I think we can just write it ourselves, right? Let's do this. Print grid. Yeah, there's no reason for us to do this. Local x, y. Local c equals... Oh, it would help if I actually did change these. Cool. So now that we're here, we can just grab the grid at x and y. There we go. Now we have a print grid function that we've written 8,000 times. So let's go ahead and initialize the grid. We initialize every single part of the grid to be period. Now we have to read in the data. Initialize grid as all free. Now we have to simulate bytes falling. So we'll do a while read dash r line do done I equals 0. We can say the line is an XY coordinates. This is super easy. We can just say grid line equals pound sign. And then we want to break. We only want to read in 12, so we'll do an I++. And then we can do if I equal 12, then break out of this. So will this actually do 12? I don't have like weird off by 1 errors, do we? I don't think we do, but I could be wrong. I gotta get my brain in coding mode. I'm fine, have some ideas about this day. I would say about approach, I will keep it for a while. Yeah, we'll see, we'll see. Because I'm guessing part 1 seems so incredibly straightforward that has me scared for part 2, you know what I mean? So we printed out hi. How many times did we print that out? 12 times. Okay. Yeah, that makes sense. 1, 2, 3, 4. 1, 2, 3, 4. I had that logic right. I'm always worried about an off by 1 error. Okay, so now we simulate bytes falling. Show the maze we have to solve. Print grid. So this will be the maze that we have to solve. That's not what it looks like. There we go. And let's just pull up the example to look at. It's this right here. It looks really good, right? That's what we have to do, and that's what we were able to generate with our terminal. So that's perfect. Yeah, I like that better. Cool, so we have to solve this maze now. So we have to solve this maze in the fastest way possible. There's no heuristics around like corners are expensive or turning is expensive or rotating. We literally just have to solve a maze. That's a very, very straightforward algorithm. So solve the maze. The way we do that is we will say start, actually let's do it up here. Start location is 0, 0. End location is 6, 6. These will change. This is just for the example. Okay. So this will be our start location, our end location. So in order to solve the maze, we will need a queue of moves that we're going to do. We're going to do breadth first. So we will just basically break once we find the first solution that works. And while the queue still has things in it. So while the length of queue is greater than 0, we'll have to push something into it first, but yeah. While the length of queue is greater than 0, we will do done echo maze is solved or unsolvable LMAO. We'll deal with that when we get to it. So what we do here is we have to push the first thing to the queue, and the first thing we push is our location. So queue plus equal start location. So what this means is we are going to first look in this location, and so we'll pop off the queue. Let me think if there's a clever way to do this. I think we can just use sparse arrays here. I don't think it actually matters that we have to shift it. So let's figure this out. What I mean by that is we can pull from the beginning of the queue, which is just spot 0, and then we can unset it. So we'll lose spot 0 and the array will keep growing to the right, but it doesn't matter. No, it does matter, doesn't it? Ah, God, dude, Bash has some of the weirdest things. What's up, Bad Cop? Dude, I just got destroyed in the chat. Look at that. Oh my God. How did you know? Who told you? Nerd. Yo, we're nerding out hard over here. Oh, man. Yeah, I'm just lamenting at pushing and popping onto a queue and Bash, and why can't it just be nice? But it's really not that bad. I'll just reshift the entire array. Because we'll end up with a sparse array, but there's a clever trick we can do where we can just set the array equal to an array of itself and expand every element. So we'll get around this. So our position to try, we will grab the first spot of the queue. Then we will unset. No, we don't even need to do that, do we? Pop off first element from array. Because now we can just do this. The queue, all the elements, :1, right? Yeah, so this just means all the elements and then start, like, getting rid of the 0th position. This is probably not the most efficient thing, so echo POS, and this should just print one position, just print 0, 0, and it should exit. Cool. Hey, it worked. Awesome. Yeah, that's how I do it, LOL. It's definitely slow, but who cares? Yo, yeah, 100%. Yeah, I keep thinking about that. Like, there's probably a better, cleaner way of doing this, but, like, I have no idea what it is. Because if you just, like, my original thought was just to do this, like, unset queue at 0, but it doesn't shift all the items. You just end up with a sparse array that starts at 1. And, like, it's cool that Bash supports it, but, like, we don't have any sort of DQ structure or something where we can grab from the beginning and the end of it. There might be some way to, like, abstract this out, but yeah, who cares? That's how I feel about it. Try this position. Let's see. Greetings. I see you're on fire, Dave. Yo, I am absolutely crushing it. I'm also on fire because my house is very warm right now, like physically. But yeah, no, I'm just crushing. I'm just going through and I'm not letting the puzzles scare me. Some of them have been very difficult, but I'm just trying to crush them. That's all I'm trying to do. Take them one puzzle at a time. So now that we're here, we're going to try this position. And the way we try this position is the first thing we check is, did we win? If position equal end location, then echo we won. Fee. Exit 0. Exit 1. Is it unsolvable with an E? Yeah, I think it is. Let's see. And then if we get down here, we have to try all 4 directions. No, not try them. Queue up trying all 4 directions. So we'll go north, south, east, and west. So in order to go north, we will say, you know, what will we do? Read-R XY from the position. So we will break the X and Y out. We'll say next X equals X, next Y equals Y. And if we want to go north, that means that the Y should go down here. We're gonna have to do bounds checking, but we'll add that later. So now we have to queue up going north, which is next X, comma, next Y. We have to do bounds checking. Bounds checking would say, yeah, in order to do that, we'll have to do this. We'll have to get the x and y from it, and then we'll have to say if x less than 0, or x greater than equal width, or y less than 0, or y greater than equal height, then continue. We'll just try again, but we won't push anything onto our queue. Now we check if we won, and now the final thing we have to do here is this logic, which I'm just going to do that many times. So there we go. No, we don't have to do this. We already did this. So we have north. We'll do south. We'll do east, and then we'll do west. And this should be it. I mean, this algorithm's very straightforward, so it should just work. It should just be a maze solving algorithm. All right, so if we're going south, we plus there. If we're going east, then we do that, and if we're going west, then we do this. Okay, I think that's it. I think we solved the maze. Is it the blinking stone ones? That was fun. Yes, the blinking stone one was the one that I believe that was the one that I could not come up with a workable solution in Bash. It was just too slow. Did I get it working in Rust? I think I did. I have to go through and re-edit the videos to even remember. I don't even remember where we left off there. But that was when someone in our chat showed us a super simple, like, just mathematical way of doing the blinking stone ones. Yeah. Yeah, I want to say I came up with some really clever algorithm, way too... And when I say clever, I don't mean that's a good thing. I mean, it was too clever, too much code. And I think Rust was able to solve it. Yeah. But again, I gotta just recheck. So we should get here if we win. We haven't kept track of any information, so all we know is that we did win. So when we push onto the queue, we should probably keep track of how many steps we've made. Let's just see if this can actually solve the maze and give us any answer in any sort of reasonable time. I have no idea if this is even working. Let's do this. I equals 0. Printf I, and then when we get, okay, we'll just run this and just get an idea. We're not moving forward. Okay, that's really good. I think I know exactly why without even like, yeah. Here, no? No, I don't know. I don't know why I just said that. What are we doing here? What are we blocked on? We're not doing something. Of course, I is gonna always be 0. I should probably do an I++, right? Okay. So this algorithm already sucks. That doesn't suck. It does exactly what it's supposed to do. It just might be too slow. These maze solving algorithms in Bash are really tough. Does that seem like too many moves to solve a maze? Someone doesn't seem right. Oh. Yes. Yes, yes, yes. We need a visited, right? I think we need a visited array. So if we were able to get something, okay, this move is valid, mark it as seen. Okay. Yeah, so if we're here, then we know that visited position equals 1, and then we know we check if we're in bounds, we check if we won, we can check if we've been here before. We're getting into loops. Okay. Okay. Oh, okay, we won. Cool. So we should keep track of something now. So let's see. what we should keep track of is the start location and how many steps we've taken. Yeah. Keep track of the start location and how many steps we've taken. We initialize it to 0. If we made it here, then steps plus plus, and then we just push that on with the queue, so we just retain it the entire time. I think this works. No? I'm doing something really simple wrong. Oh, I think because I call it pos, right? Yeah, let's do this. This is the problem. Yeah, once we break it here, we should set key equal to x comma y. If key equals end location, visited key. This should work. This should just give us the answer. Some of them are really memorable, especially if you had fun solving them. It's so true. It's so true. The thing is, like, this is gonna sound so weird. If you haven't done like content creation and streaming, you might not be able to fully like vibe with what I'm about to say, but like, there's coding on my own and then there's coding to stream. So like when I'm doing this, I'm also focused on like, you know, being entertaining a little bit. So sometimes I'll forget like key details of the things I had to solve. Even when I solved them in the moment, it's not until I rewatch the videos where I was like, oh, that's what I was doing. Or wow, that was a really simple bug I missed. But yeah, like there's definitely some that have stuck with me. I really like Guard Gallivant. I really liked finding the Christmas tree and the robots. Like there were some puzzles that really, really stuck out to me. I really liked implementing a computer. Like I thought that was super cool with all the different instructions. Yellow, what's up, JH? How you doing? This should just work. Okay, prints we won. We didn't print out the steps. So once we win, we should do an echo. We won, echo, took, steps, steps. Took 12 steps. That doesn't seem right. I think it was supposed to take 22 steps. Yes. So in order to win this example, it was supposed to take 22 steps. 12 was just how many obstacles there were. So, something didn't quite work out how we were supposed to. What are your thoughts on ZSH? I don't know. Don't really use it. I don't have too many thoughts on it. I'm going to remember 2019 day 25 forever. Oh man, I'm scared now. 2019 seems to be like an infamous year for this. Now let's see, we read this out. Oh my god, I'm so funny. I'm looking through this. I didn't put any obstacle checking. I got so concerned with making a maze, I never once checked for obstacles. At no point did I check for obstacles. There's no collision. Oh my god, that's so funny. Check if we have collision. Come on. We could also cache collisions to just kind of skip out real quick. It's kind of funny. We could put the collisions in the visited, but whatever. Let's see. Yeah, we just didn't do collision. That's so funny. Key. So of course it's 12, isn't it? 7 by 7. Yeah, so I'll move 6 in one direction, 6 in the other. Yeah, that probably is the fastest way to get there, isn't it? If C equal pound sign, then continue. This should be 22. Okay, hey, we got it. 22. Took 33 iterations to get to 22 steps, and we nailed it. Okay. Cool. So now that we have that, Let's see. Now we need to simulate the first 1024 bytes. Oh yeah, wait, where do we do 12? Yeah, this is a magic number. Let's do this. Num bytes equal 12. Let's get rid of all magic numbers. There we go. So now what we can do here is we can say, like, let me think about how I want to do this. Case $1 in. So we have to give our command arguments now. If we give it the example argument, we get that. If we give it the real argument, we'll get this. This way we can run the same program, but we just give it different arguments to let us know how we're going to run it. Cool. So the width of the real puzzle, I'm looking through the website to try and remember, 0 to 70. It can go to 70, so the width is 71. Okay. 71. 71. Number of bytes is 1024. And the ending location is 7070. Okay. Cool. So now we can do part 1. Let's cat the real input, give it to part 1. Cat real input, let's cat, what was it? We'll cat the example into part 1 example. And we get 22. Now we will cat the real input into part 1, and we'll run it with the argument real. Oh, that puzzle looks cool. That looks sick. It's like a corrupted... I mean, of course it is. But I didn't think all the memory would be in the top left and the bottom right. That's cool. It took 432 steps to get there. Okay. The puzzle looks really sick. Let's go through here. 432. Hit enter. Let's go. Let's go. Oh my god, are things getting easier now? That's the right answer. You are 1 gold star closer to finding the chief historian. Sick. That's what I like to see. Nailed it. That's one of the fastest puzzles we've ever done. I'm scared now. What does part 2 have in store for us? GG's. Thank you. Thank you. Part 2. The historians aren't used to moving around in the pixelated universe as you are. You're afraid they're not going to be fast enough to make it to the exit before the path is completely blocked. To determine how fast everybody needs to go, you need to determine the first byte that will cut off the path to the exit. Oh god, okay, okay, we're adding a temporal dimension to this now. In the above example, after the byte 1, 1 falls, there is still a path to the exit. This is 1, 1. However, after adding the very next byte at 6, 1, so here, there is no longer a path to the exit. Oh boy. So in this example, the coordinates of the first byte that prevents the exit from being reachable are 6, 1. Oh, wow. This is cool. This is really cool. This is really cool. So we have to simulate bytes falling. I'm going to talk about the brute force solution before I even try and optimize it. Here's where I'm being guided to do. I'm being guided to drop a byte, see if it's solvable. Drop a byte, see if it's solvable. Keep going until it's not solvable. That may not work. Obviously, this puzzle's kind of big, but it's not that big. It's 70 by 70, 71 by 71. What's up, Ash? Yo, how you doing? Simulate more of the bytes that are about to corrupt your memory space. What are the coordinates of the first byte that will prevent the exit from being reachable from your starting position? Provide an answer as 2 integers separated by a comma with no other characters. Okay. So let me do this then. Okay, I really like this puzzle because of how after the past couple of days they've been really hard. Don't get me wrong, they're fun. But they're exhausting. These puzzles are exhausting in the best way. I went snowboarding last night for the first time. I'm not kidding when I say this. For the first time in 17 years, I went snowboarding. It was the most fun I have had in so long. It was so incredibly fun. But man, I was shot at the end of it. I was completely exhausted, but it was the most fun I've had in a while. That's how these puzzles feel. It's a similar thing. It's not physical, it's mental, it's different. But like, I'm so exhausted at the end of it, but man, you feel so incredible. Absolutely incredible. Black diamond? Yeah, no. Green and maybe some like blue. No black diamond. Back in my heyday, yes. Yeah, I don't know about so much now, but I want to keep going, so we'll see how it goes. Brute force always works. Eventually. Yo, it's true. It's actually true. It does work. Eventually. Just joined. I want to know what the rest of the shirt says. Hey, that's a really great question, because I will show you, and then I will explain why it's a great question. You ready? You wouldn't exit Vim? It's not possible. And it's a great question because you can buy this shirt on my merch store. That's right, it's my merch. I came up with this design. I like to shit post on Instagram, and if the designs are good enough, I turn them into merch. So I'm going to go ahead and throw you a link to my merch store because I don't have any sort of bot that can do it for me because I'm new to Twitch. So look at this. I'm going to do exclamation mark merch. And look, now my bot replied. How cool is that? That's totally a bot, not just me. Yeah, I'll put it in YouTube chat in case anyone's curious about it as well. But yeah. Alright, so for this puzzle now, we're in part 2. We need to simulate more bytes starting. So we know that 12 bytes is safe for the first one, and we know that 1024 bytes is safe. So what we can do here... We're in part 2, right? Yeah, we're in part 2. Okay. Let's get rid of this. Get rid of this. And get rid of this. We could parallelize this. I'm thinking way down the road. So we're gonna have to put this in a function. Because now the maze being unsolvable is our win condition, and the maze being solvable is our lose condition. This is interesting. We've just reversed the win and the lose condition. Let's do this one. Solve maze. We'll make a function called solve maze. And don't worry, we're gonna clean it up. We have a function called solve maze. We have a queue where we push our start location. We make a visited array. Just gotta make all these bad boys local so we don't bleed any scope. We don't need to keep track of the steps. We don't care how many steps it took, we just need to care if it's solvable or not. Yeah, if anything, this logic has gotten easier now. We'll just need some sort of identifier for the maze. So in order to do this, let's think about this. I'm going to move all of the code that actually does anything important down to the bottom so we can stop jumping around code so much. So we'll just have functions up here. So all the way at the bottom of the code, we will create the maze. We'll initialize it. We'll simulate bytes falling. We don't need to bother showing the maze. We don't actually care about it. So now what we will do is we will just put an infinite while loop here because I assume both of these are solvable. We will drop a new byte, try to solve the maze, repeat if maze was solvable. That's it. That's our algorithm right there. It's super simple. So in order to drop a new byte, we need to read another line from standard out, from standard in. Read dash R line. That's our line. So we could say, let's not even echo it. Let's just do this. Last line equals empty line. We're gonna cache this in a variable. Wait, we don't even need to do this. I'm overcomplicating this already. We read a new line. We're gonna set that line to be an obstacle. And then we're gonna try and solve the maze. Solve maze. If solve maze, meaning we were able to solve the maze, then we continue. This maze worked. Try again. If we weren't able to solve the maze, then we're done. This is as easy as it could be. Oh my god, we echo. This obstacle broke the maze. Line, exit, 0. That's it. That's our code. This is it. Like, there's nothing else we need to do, right? What's up, Fallen Ear? How you doing? Welcome to the stream. This is our code. This is it. This is all we need. I can't think of anything else that we could possibly need here. We could put some prints. We could do this. I equals num bytes. Every time we read a new one, we could do I++. And then we could say, you know, printf trying percent d r or dot 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 r I. We could do that. We can do that. Let's see if it's fast enough. Yeah, that's what I'm worried about. Actually, let me get an idea, because we only did the first kilobyte of memory. Yeah, 1024. Okay. Not the end of the world. It's so much slower now, but let's not decide for it. Part 2, example. We can still win. Oopsie. The obstacle broke the maze. 1, 2. Nope, that's incorrect. 1, 2 should not break the maze. I'll have to go through. There's. I'm not surprised it didn't work. I just need to figure out why. Just make sure that we like trash every one of these elements. Yeah, we redeclare visited, we redeclare queue, we don't redeclare grid, but we don't have to. Putting obstacle at 1, 2, the obstacle broke the maze. Wait, hold on. If solve maze. Oh, I think I just had my return codes bad. I shouldn't have swapped the return codes. I tried to be too clever. Yeah, I just tried to be clever with my return codes. Solve maze is the name of the function, so it should return if we're able to solve the maze. Okay, the obstacle broke the maze, 6, 1, and if we go to our web browser, 6, 1. So, I mean, we're doing it. Let's go ahead and get rid of some of those echoes. So when we run it, it'll look like that. Cool. So now let's do it with the real input. I mean, let's see how this actually fares. The nice thing is we know that... we know the real input is 3450, so that's just what we have to run up to. Why does it break immediately? 2. Why is it exiting with 2? Oh, what's up, Ash? You found the custom emotes. Look at you. Oh, I'm giving it real input.txt as an argument, not the word real. I probably should just... I could take the file name as an argument, but... Oh. Well, I see the problem. I see the problem. Oh, man. But, like, okay. Here's the thing. Here's the thing. This is not a bad thing. Here's what we can do. There's a lot we can do. First of all, we already know that it made it to 1060. So now what we could do is we could say num bytes is equal to argument 2 or 1024. So now we can start it at 1060, which is nice. What we also know is that eventually it'll fail. So we can actually just binary search for it. Is that the word I'm looking for? Like if we go 2000 in, no, it's still solvable. If we go 3000 in, it's not solvable. If we go 2500 in, oh wow, it goes a lot faster. That's really cool. That makes sense. It's probably failing way faster. Yeah, this doesn't seem bad at all, right? Like I could literally just find out where it's going to fail. Look how fast it's going. So this number will get up to 3000 like within the next 20 seconds we're going to have an answer. There we go. I mean, this is the answer, right? If it works, it works. That's what I'm saying. Like, I don't know. This didn't seem too bad. I knew what the starting position was. I knew how many were in the file. I could just, like, cut into it and basically just search for it. Is it binary search? Is that the term I'm looking for? Because I basically just kind of cut it in half and then figured out where to go next. I didn't quite do binary search. Mine was more like, you know, I was going by feels and vibes. So, you know, it is what it is. But yeah, binary search. That's what I'm imagining. You cut it in half, and then if it's less, you go cut that in half, and you just keep cutting in half until you... Tree structure. I'm going to constantly do this thing for a tree structure. Told you. Looks like a record. Yeah. Let's see. 41,70 is the one that broke it. So if I go here, and I type in 41,70... What? Okay. Hold on. That one isn't right. If you're stuck, make sure you're using full input data. That's interesting. I'm a little bit surprised. I'm so surprised that I don't believe it. Well, I believe that it's not right. I just believe that I probably got something out of order. Like, I'm probably just, like, not printing the right thing. That's my thought process, but we'll see. Fancy chat. That's right. We got a fancy unified chat now. How awesome is that? Let's find out which one actually broke it. $41,70. Did I not type that in correctly? It probably won't let me submit it again. I know there's like an exponential backoff. So 2908 is where it fails. I think it starts above that, right? Yeah. Yeah, I'm just off by 1. 4170. Let me look in the real input. 2908 is the line number it appears on. That seems right. Let's see. You had a similar mistake in yours? Ah, interesting, yeah. Swap to terminal view, still in the browser. My bad. My bad. Good call. Yeah, so all I was doing here was I was just kind of like iterating forward. So like I added some debugging. So now I just print the line I was on that caused the obstacle to break. So if I start at 2905, it counts its way up, gets to 2908, breaks because there was an obstacle at 4170. What are the coordinates of the first byte that will prevent the exit from being reachable from your starting position. Provide the answer as 2 integers separated by a comma with no other characters. That's it. I mean, I grabbed it straight from the file. Unless I'm doing something wrong in my logic. Let's just go over my logic. A good thing to do is just check to make sure I've declared everything local, because then you get things that are, oh my god, what is that emote? Oh my god. Because I don't want to get anything leaking here. Declare -a visited. This should wipe it out. While the length of the queue is greater than 0. We pop off, recreate the queue, local X and Y, read it, do some bounds checking, check if we have a collision, check if we visited it before, check if it's the ending location. Otherwise, we mark it as visited and we check all 4 directions. I mean, come on, that's it, right? Maze is unsolvable, return 1. We declare the grid here. We set the X, comma, Y. Doesn't matter that we do these, and doesn't matter what order we do those in. We simulate the bytes falling. Oh. No. I would say our I might have been slightly off, but it doesn't matter because, like, we grab the line, we set the line. This is our coordinates, this $ line variable. And then if it breaks the thing, we just print that line broke it. I mean, that's exactly the last one we pushed in there. So how could it not be that? Here's what we can do. Let's print grid. So when it gets there, it should print one that's broken, meaning we can't get from the top left to the bottom. I'm not tracing this. I'm not looking through this. Are you kidding me? I don't want to do this. Here's what we'll do. We'll print grid. Here's what we'll do. Make dir frames. We'll print grid into frames $I dot text. Cool. Now if we ls frames, let's generate the one before it. I should really fix that, but whatever. Oh, I'm printing it down where, yeah. I'm gonna come up with a brute force emote. Hey, that's a good idea. I like that. Here's what we'll do. We'll write out the grid after we've set it. ls frames. We have 2 frames now. Awesome. So now what we can do is we can color diff. This is not the greatest way to do it. Is there a good diff program to show the difference between 2 things? Okay, all we did was add that one line. That doesn't help us. That doesn't help us to know that. All right. What was the number that I tried? 41, 70. So if we vim 2908, we have to go. Yeah, it was 49, 70. But I think it's going to be off by 1, so it would actually be 50, 71. This is the key right here that we added. So where my cursor is at 50, 7150, 7150. So if we go there, 2907. $71.50. It's already there. What is it adding? Yeah, because... Am I doing things backwards? No, I shouldn't be. Okay, yeah, so this is actually... Okay, right. Let me look at the real input. 41, 70. So 41 in the X direction, 70 in the Y direction. That's why it's at the bottom of the file. because it's 70 in the Y direction, and it's 41 over. Okay, so that's, yeah, I just had it backwards. So if I'm looking at 2907, yeah, it's all the way at the bottom of the file. It's here that I got added. That wouldn't change anything. Right? Oh, it would. It would. It's this key right here. Is my logic bad? Is my maze solving logic bad? Shouldn't be. Yeah, once we mark a spot as visited, we don't ever need to go back there. Doesn't look like that point would break it. Yeah, I'm not sure. I'm gonna try it again. I know it's stupid, but like I just want to make sure. I want to rule out that I did any weird copying and pasting, and I'm not just sitting here spinning my wheels for no reason. You know what I mean? 41,70. Okay, it's not right. Then we're good. Just wanted to make sure that I wasn't, you know, debugging something that wasn't a problem. All right, let's start doing some thinking. Where do we mess with grid? We add them here till we hit the number of bytes. Then we add them here. And I don't think we ever modify grid again. Yeah, we only... So that's cool. Every time we do the algorithm, we never actually modify the grid, which is good. Could it be that because it breaks earlier and you have it cut? Of course it could. Yeah, it could be. I have no idea. I don't know what could be causing this. Yeah, we read a line. Trying. Adding. Line. Yeah, you know what? This isn't serving me anymore. Let's put new lines here. Okay. Yeah, so we added 41,70, and then it became unsolvable according to our logic. Yeah, I mean, it should work. I'm like in disbelief that this didn't work. Is it this that's wrong? Because I think we stopped putting steps in? Or what were we storing there? Nothing. Oh, you know what? It might have just literally been that I had extraneous data being pushed to my queue. Literally, that could be it. Like, I think it could have possibly been a bug. Because now that one fails. Like, let's start it at, I don't know, 2,000. Yeah, okay. I wonder if we just... Yeah, I wonder if I just literally, it was just a bug. I mean, that'd be nice. That'd make me feel better. Yeah, see, now it breaks in an earlier position. Like, now it breaks at 2904. Literally, I just had a comma 0 in there. So what would have happened if we trace this is, where is it? Yeah, where I pushed the first thing out of the queue, I had a comma 0 here. So what that means is where we break it off here, this would be X and Y would be set to 0, comma 0. So we'd have a really weird key there. I don't feel like tracing through and finding all the ways that'll break. But if I run this, we can see that we break at 5627 at step 2904. Okay. Cool. Yeah, I think this was just a bug. Which makes sense, because my logic was sound. 56,27. That's it. It was just a bug. It was just a bug. That's all it was. That's the right answer. You are 1 gold star closer to finding the chief historian. Ayo. Let's go. Nailed it. Nailed it. It was just a bug, guys. Oh my god. That's so funny.